Hey, it's Bob Duffy with Intel here, once again in Stable Diffusion using my Intel Arc GPU. And I want to show you guys two things in this video. One is how to create high resolution images like this right here using SDXL on an Intel Arc GPU. And the other is how to do really fast image generation using something called LCM. So stay through the whole video to watch that and see how I create 12 512 by 512 images in about the time it takes for me to finish this sentence. Now, the last time I was showing you guys this, we were creating some pretty cool images like this. And I even showed you how to do in-painting, but all of this was done at 512 by 512. And I think it came off pretty well, but I want to take it to the next level and show you guys how to take advantage of SDXL, which allows you to generate images at a higher resolution. And you can do this within the Automatic 1111 interface with Accelerate with OpenVINO. And you can also do it using the SD.Next webui using Intel Python extensions. And I'm going to demonstrate that as well. But first, let's get back in this because we know what Automatic 1111 is if we watched the last video. Really not much to do differently here other than that you need a different model. You need a higher resolution model in order to get higher resolution images. So you can get those at Hugging Face or over at Civet AI, which is the site that I showed you guys last time. So if you go to civetai.com, click on the models area, and then over on the filter area, you're going to want to make sure that you have SDXL 1.0 selected, and then you're going to want to make sure that your model type is a checkpoint. And then you can find something that you like here. Now, what I'm demonstrating for you guys is night vision. Night vision is a really nice model because it doesn't require any refiners. You can just use it right out of the gate. And if you just look at this stuff, it's absolutely amazing. It's beautiful work. Again, the fidelity on this stuff is just beautiful and gorgeous. All sorts of skin detail, hair, everything like that. No need to go back and in-paint as I showed you guys before. It's all good to go as it is. So what we're going to want to do is find the model, and you're going to download this, and you're going to want to put that in your, let's see if I can find the right folder here. Go to your, wherever you have Stable Diffusion Automatic 11 installed, go into the models folder, then go into Stable Diffusion, and this is where you're going to put that file. Then when you're in Automatic 1111, you're just going to want to refresh. Just click this here, and then it will show up in your list and you can use it. The rest of everything is pretty much as I demonstrated for you guys last time. Obviously, you're going to want to up the resolution. I suggest 1080 by 1080 is a good resolution. Go ahead and give that a shot. And then within the Accelerate with OpenVINO area, the only other thing that you need to do is make sure that you have this checked. The loaded checkpoint is SDXL checkpoint. So that's all you have to do. There's no additional refiner needed or anything like that. Some models do require that, and you would select those here. But for this particular model and checkpoint, we don't need that. So we have night vision selected. We're all ready to go. And let's do the guy with the beard again, I guess. So let's do that. Man with beard, modern hairstyle. And I'll just have my negative prompts as usual, so it's realistic and it's appropriate. So I'm going to go ahead and click generate. And as we showed you guys before, is you'll see this getting going here, and you can see these other ones took about 14 seconds to go. It's a high resolution model, so it takes a little bit more time to generate. Before the 512 by 512s ones were done in maybe a couple seconds, and here this is done in 14 seconds. Let me open this up in a new tab so we can zoom in, but you can see that, I mean, we've got a lot of detail in the skin. The eyes are perfect. The hair has got a ton of detail on it. It's just, it works. So there, like I said before, there's no reason to go in and in-paint this. This looks really good. And now it's just about prompt crafting. And again, this compared to this at 512, which is good, but it's just softer and fuzzier, and it just doesn't have that fidelity. So that's the advantage of using SDXL. Again, you can use this in Automatic 1111 with the Accelerate with OpenVino script. Now, as we talked about before, and I showed you guys before, when you do it for the first time using Accelerate with OpenVino, it's going to have a compile time. And just expect that that compile time is going to be longer because we have like a 6.5 gigabyte model here. Now I'm going to shift gears and we're going to move over to SD.Next using IPEX. And that's going to be a little bit different because it's not going to necessarily have as dramatic of a compile time. Things are a little bit more smoothed out. So depending if you're changing gears a lot, if you're changing your resolutions, changing your models a lot, that may be a little bit smoother for you. But for the most part, it's a very similar experience. So I'll see you over in SD.Next. Okay, I'm back, but in a different interface. I'm in the SD.Next web UI for Stable Diffusion, which looks a lot like Automatic 1111. But I want to back up a little bit and talk about why we're looking at this in comparison to A1111. In my previous video, I talked about this article that I have posted on arc.intel.com. And in that article, I talk about 3 different ways for doing image generation on an Intel Arc GPU. You can use GIMP, the photo editor, with a plugin. A1111, which we demonstrated in the last video and in the first half of this one, or you could use SD.Next web UI. Now, at the time that I wrote this article, this web UI was the only one that supported SDXL, so higher resolution images. But as you saw, and we just did, you can do this on A1111. So why would you choose SD.Next web UI instead of A1111? Well, this supports Intel extensions for Python or PyTorch. And IPEX is absolutely amazing. It's another great software technology from Intel. It's a little bit different than Accelerate with OpenVino, which has a bit of a compile time as you change models and you change settings. IPEX does not, and you'll actually see that in action. So you may find that if you're doing a lot of changes in configuration in your web UI, you may prefer to use SD.Next with SDXL support. So in order to get this going, you would follow this link here, which is going to take you to an article from the community who's maintaining this. And they provide some instructions for you here on Windows or on Linux, either natively or through WSL. Now, I did the Windows native path, and I found it super simple. Just like A1111, you have git commands. So you just clone this repo, then you switch over to this folder, and then you run this command here. It will install everything that you need. And then after it's done, you'll just run this anytime that you want to get into SD.Next. And then you end up in here, something like this. Now, just like I showed you on A1111, you're going to need an SDXL model for this. Now, this can do SD 1.5 or SDXL, so you can get a 1.5 model by default. So if you want an SDXL model, you'll need to go, like I said, either to Hugging Face or Civet AI in order to get that model, as we demonstrated earlier. But another way to do this, which is really cool, which I love, is you can go over to the Models section here. If you know that it's night vision that you want from Civet AI, select, okay, the model type is SDXL, and it's night vision. If I can type. Yep. Typo. Fat fingered it. Okay. It's going to go ahead and search, and then you'd have the model right here. You click download, and it'll put it in the appropriate directory for you. But mind you, it's 6.5 gigs. Make sure that you've got enough room for it, and it's going to take a while. But I've already done that work, and we're ready to go. Oh, there's one other thing that you need to do. Over in the System tab, there is an Execution Backend option under Execution and Models. There's either Original or there's Diffusers. By default, it's set to Original. You're going to want to switch it to Diffusers, click Apply Settings, and then restart your server. And then you should be good to go. If you get an error as you're trying to run this and it says something about the wrong size or the model the wrong size, just go ahead and try that and see if it fixes it. So we're going to do this apple to apples just like we did before. Same exact prompt, man with a beard, same negative prompt, size 1080 by 1080, just as we had before. And we're going to click generate. And then just as you see in A1111, there is a command window and it will run through that. Now on A1111, it took us about 14 seconds to do it using the accelerate with OpenVino script. Let's see how well IPEX does here. Okay, about 15 seconds or so, so maybe a little bit slower. But if we look at it, it's just as good. Great detail on the skin. Everything looks absolutely beautiful because, hey, it's Stable Diffusion, same prompt, same exact model. It should look the same. Now, that might have been like a hair slower, so why use this? Well, this is why. So as you make changes, let's just say that we wanted to change the dimensions of this. I'm going to run again, and it's getting right into it. Now, if you remember when we did stuff like this on the Accelerate for OpenVino, it had a little bit of a compile time. So every time that we made a major shift or change in a checkpoint or sampler, then it did this extra compile time. Again, this goes lickety split. Just for example, I'll change my sampler here, which added an extra compile time, hit generate, and this goes right in. And we can see this is hitting my GPU. My Intel Arc GPU is getting hit here. You will notice I do not have my integrated graphics listed here. I had disabled it. And that is something that is mentioned in the instructions here, is that you will need to disable your iGPU. So if that's a deal breaker, then maybe stick with A1111. But if not, you might want to give this a try. Okay, so there it is. And then just like last time, I showed you in painting. Now, this image is really good, so I don't know that there's a good reason to inpaint, but we'll do it anyways. Just so you can see male eyes, click generate. Now what this should do is it should just edit this area where the eyes are, and we'll get different eyes for this guy here. Now, I guess, I mean, these images are really good. There's probably not a reason to switch his eyes, but maybe if I wanted to make him clean shaven, I could do that. So yeah, that worked out really well. But the point is we shifted gears quite a bit. We went from, changing the size to changing the sampler to going to in-painting, and there wasn't that compile time. So as you're switching things up like that, you might find that this is a bit smoother of an experience. If you're pretty much dialed in on your settings and you just want to generate a bunch of images, A1111 may be the right choice for you. But choice is key. That's what this is all about. It's like this is my article says. You've got 3 options here. Choice is good for doing image generation on an Intel Arc, GIMP, A1111, or SD.Next. And I promised I'd show you LCM and fast image generation on an Intel Arc. So if you don't know what LCM is, it's Latent Consistency Models, and it's the latest way to generate images using Stable Diffusion, and it's super fast. So we can see images here just in 4 steps. Typically, and what I was showing you guys before was around 20 steps to create really good images. So this can be done in just 4 steps, and it's super fast when it does it. So if you want to do this on an Intel Arc GPU, use SD.Next. If you download the latest version, LCM is supported in the main branch. And all you need to do is what I showed you before, is go to the models area and search for it. Search for LCM_DreamShaper_V7, and that will give you this list here. Select this one and download it. Then that will put it in the appropriate directory. So then you can go over back to your text tab, refresh your model list, and it will be there. You should see it listed and written just like that. So select that and you're ready to go. One thing I need to tell you is negative prompts don't seem to be making much of a difference. So make sure that you're crafting your positive prompt effectively. Also, set your resolution down to say 512 by 512. And then your sampling steps are usually at 20. Reduce those down to about 4. And then I'm going to go ahead and kick this off so you guys can see what's going on. I've set my batch size to 3, which is doing 3 images at once, and then it's doing 4 of those each. So you'll see each of these going here, right? And you'll see that we did, 12 images in 9 seconds or so. So you can see that is much faster than we were seeing before. So you can generate a ton of images, get to something that looks right to you, and then take it to the next step. For instance, you can go over to your image-to-image area, take an image here that you generated with LCM, then you can switch over to, say, night vision and generate a high-resolution version of that. So just use the same prompt, maybe set your diffusing down or denoising down to like 0.3 or 0.5, and then you'll end up with something similar, and you'll get a higher resolution version of that. So you've got a lot of options right now. You've got SD 1.5 and SDXL for high resolution image generation with access to Hugging Face and Civet AI models. And you have LCM for super fast image generation, all working on an Intel Arc GPU. But before I go, I do need to invite you again to our Insiders Discord. Go to discord.gg/Intel. Check out our generative AI community there. We'd love to chat with you and see what you guys are doing. But that's a wrap for me. I hope you enjoyed it. I'm Bob Duffy, and we'll catch you later.